Hello friends, hello and welcome today at Toulouse Airport. Frank Hazal here with ATR planes behind us. Today we have the chance to do a test flight on an ATR 42 with Cyril Bonjour.
Hello.
Proud test pilot. What kind of flight are we doing today?
So it's a test flight to check the sensors we installed on the leading edges and see how they perform in the relative wind. And also to record parameters that will allow us on the ground to see if the system is reliable so we can implement it on all production aircraft.
And now, watch out for this. We're going to stall, guys. Come on, let's go. Stalling is something we do regularly on a test aircraft.
Yes, on a test aircraft, yes. Because we're going to go to the lower speed limit, so we do lower limit, upper limit. And here, the purpose of the flight is to reach the activation, the triggering of the pusher. All right, the pusher is a system that moves the elevator all the way, triggered as soon as we reach a certain angle of attack. All right, and as soon as the pusher is activated, we check the speed, it deactivates, then we regain control.
We take control of the flight again. No, but at what speed does the plane stall?
We're going to go down to 70 knots, depending on what altitude.
We're doing that now.
We're doing that at flight level 150.
That gives us some leeway.
There you go, 5,000 meters, that's fine.
How far do we fall when we have little...
In under 1,000 feet, we recovered and stayed to listen to ourselves.
It's a good plane. There you go. I'm following you.
I'll leave you with Pascal. Thanks.
Hello. For the rest of the briefing, we have Pascal, who also shares a bit of a past with me. He was in 21F in the French Navy when I was in 23. What were you doing back then?
I was a flight engineer.
So today, what are you doing here?
So, actually, I'm a test flight engineer. So after my year at EPNA, I qualified as a test flight engineer. And so, in the English version, I'm a test flight engineer, okay, and I work on prototype flights or production flights. My role on board is either as the third crew member. Yes, so I help operate the aircraft, handling the mechanical and systems part.
So, we can add the center seat, which will be adapted so that you can participate.
So there is always a third person in this version.
Of the machine.
It's always there, but actually, I occupy it on flights, mainly proto, but also prod. Machine management is fine. When there are special test flights, we have engine models to make, engine cutoffs or tests, or engine annoyance, what we call OK. It's good to have a third person who steps back a bit and can watch over that side. I can also have a role, I'll have a role in monitoring the aircraft's configuration, which is really important. On the prototypes,
we talk about flap extension.
When we talk about aircraft configuration, it means that if, in the aircraft, we're going to test new systems, whether it's avionics, we can add extra seats, we can add an additional audio configuration, and all of that involves a lot of modifications. It's really my role to closely monitor the overall configuration of the aircraft.
And here it's equipped with a lot of systems.
You can see there are consoles. So on both prototypes, we have an FTI, which is flight test instrumentation. And this configuration with the screens can be changed at will, depending on the flight, with engineering at the prototype level, which will display all the different system pages. So the flight test engineer in the back can monitor tests as they occur.
So here, it's almost a normal plane, except that it has a lot of extra sensors everywhere.
Well, yes and no, that's kind of it. But there are also systems that aren't necessarily in use yet, and that we're currently evaluating and testing. For example, the engines. Then, for example, you need to have an engine with a new system that we're going to test over several flights, report. And then, maybe this version will be accepted and used in a pre-release way before production.
Because as a reminder, the ATRs have the Falcon Eye, which means that with augmented reality glasses, you can see through the clouds. There's the new generation of engines that has just been approved, which will be arriving very soon, and it further reduces fuel consumption. We're already at 2 liters per 100 kilometers per passenger on the ATR 72. Here, it's a test on the ATR 42. But that means there are constant developments. We always talk about the ATR 42, the ATR 72, but actually there are lots of versions and lots of improvements. What we were doing 10 years ago is nothing like what we're offering today. That's exactly right. You have to understand that on this flight we're doing an experiment, meaning the plane we're going to fly on isn't certified yet. It's an ATR 42 that looks just like all the other ATRs from the outside. Except that we're going to do things that are a little bit extreme. For starters, there are brand new sensors to check safety. There are a lot of things that will be monitored, and we're also going to do experiments. We're going to do what's called a stall. First, to train the co-pilot, apparently. This is one of his first flights where he'll be able to conduct these operations. And a stall, what is it? That means my plane will no longer have air flowing properly over the top of the wing. Lift. What makes a plane fly is the air that flows. And there are plenty of reasons why this can happen. But basically, we're going to fly so slowly that the air no longer flows properly. And so my plane is going to nose down. That's something exceptional that we never experience in civil aviation, because it means we're pushing the plane to its extreme limits, and that's what we're going to do right now. Could you switch to the map on the right there?
Yeah, that's the map. But yes, basically they're taking us that way. You see, at that point, that beautiful rock, so the middle, you trace the line with your hand. Here we reach level 170, which is about 5 kilometers, 5,000 meters. We're going to take some turns under the G-force load, but it's... So first I'm going to stabilize at 202. So we're going to start making right turns. 602. Yes. throttle and good speed, so heading. For the next angle point, we'll set MCT. Yes, thank you. Trim speed, it will be 130. Yes, I displayed it for you. Okay, so it will be a stall. In clean configuration, we don't go through the icing AOA directly, so we'll have the stall warning, non-icing, and stick pusher. Stick pusher, 102 minimum speed, 95.9. Okay, 95. Listen, Jerome, when you're ready, final, you trim, it's good. Connect the increase in pitch to your speed trim. You set the pitch, you connect it to your speed trim, you add more, you lock it in. The speed trim will start to turn, it will go. Now the RPMs are increasing. That's the shaker you're hearing, with the stick vibrating and the pusher at 101 knots. It's clearly displayed. Now you can give it more throttle. How much did it lose there? There we took our time, 800 feet, the drop was well accelerated, and then we did the recovery. But if you go faster, you can roll. We go up to 110. I'll give you the next turn, Cotier. Are you ready? Do you agree? Yeah, we'll finish in 3, but I won't make it long. You go up there. We have a bit of headwind. We're not taking too much pitch. At this speed, the gear is down. Yeah, the gear is down. I've never flown 25 knots above trim speed, so we'll be flying 25 or 35 knots to do it. 35 knots, 35 knots, 35 knots. Trim speed, 103 knots. Okay, 103 knots. There, I bounced in the layer. I don't know. Normally, it shouldn't be too bad. If you haven't adjusted your trim, it's a bit nose down, so be cautious. When reducing, push simultaneously, or the drag outside will prevent it from working. There you go. We're already in the descent, and now you can start to reduce. Go ahead, reduce, and push, 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 push. You need more than that. If we look at the telemetry, there you go. We'll adjust the trim if needed and use some thrust to go below. It's not a problem. Minimum speed, it's good. Okay, minimum speed, 74. Come on, 79, move whenever you want. There, you want to reduce pitch because you already have drag. You see, as soon as you lift the nose, it gets worse, so we hold your attitude. There you go, and once the speed trim 3.2 arrives, you can pull back to control it. Passing 85 knots, flight idle is set. I'm continuing. And we didn't get the pusher, it's okay, 75. I can take it. Go ahead, we missed the pusher. Just to check, we didn't get the pusher. I think you have a speed. I have a very low speed. At the end, I was at 5 or 10. 75, yeah. I was only going to the buffet onset, you told me? 75 knots, 75 knots, 74. There it was. You got it because I pulled more, but your speed trim was stronger. Take the plane again. I've got the power. You go full throttle, and I'll retract for you. Were you very close to the pusher on the previous one? Yes, yes, yes. It's very small. It's a shame. I feel a bit cheated because it's magnificent. We're arriving in Tarbes, facing the mountains.
Milwaukee, hello, cleared for option runway 20. The latest wind 280 degrees for Chinook.
We're doing a touch and go, downwind, touch and go. So we're already in the process of coming in.
And are you doing right-hand circuit?
Yes, I'm doing right-hand circuits.
Understood, we're going downwind, right hand exactly.
So, are we happy with this flight?
Listen, the results were as expected, not a single failure, and the system worked well. So I think our engineering department will be happy, and you too, I hope.
We really liked it. The 60-degree bank angle is something we don't do in a commercial flight.
Oh no, the plane is limited to 27 degrees. The 60 degrees is what we call doing maneuvers. For pilots, it's to remember how to fly manually.
We pushed the plane to its extreme limits.
To be able to reach 2G, we were limited to 2.5 G here, we reached 2G. So, as I was telling you, in terms of the flight envelope, we did 2G, we did the pusher. So low speed, and the next flights will be high speed, 0G, that's it.
Well, I surprised you there, honestly. With the low vibrations we had during the stall, I was expecting something a bit more like what we did in training. No.
That's why we added a shaker to this plane. You saw the control stick move, then we activated a pusher. The plane is designed so there's no buffeting like on other planes. We use a shaker to simulate buffet and a pusher to signal you to proceed. Without these, your plane could go very deep into the stall without buffet, which can be dangerous. With steep pitch angles, that's the artificial method, but it's included in aircraft certification and design. To do this,
How many flights are needed for full validation?
we have 2 left in the campaign.
My friends, I hope you enjoyed it.
I hope so too.
Stall, 60-degree turn, doing it all. Big thanks.
There you go, thank you.
Thanks, ATR, that was awesome. Let's show it from the outside too, since it looks great. There you go. All right, friends, we'll see you very soon for new adventures.